Alright, problem number 15. Find the value of each constant, j and k, that make the piecewise function continuous for all values of x. Well, the first thing we need to do is we need to figure out what are the values of x that we're even looking at. And to do that, we need to break down this absolute value inequality. So let's just start with this top one. Since the bottom one is the exact same, it just has a different inequality symbol. Okay, well, how do you break it up? Well, you take the positive version, so x minus 1/2 less than or equal to 3/2, and you solve it, right? So add 1/2 to both sides. X is less than or equal to 3/2 plus 1/2 is 4/2. 4/2 is 4 divided by 2 is 2. So it's telling me x is less than or equal to 2. But this is a less than or equal to inequality, which means that I have another one. It's an and, because it's less than, so I have x minus 1/2 is flip the sign, greater than or equal to, change the sign on this side. Instead of a positive 3/2, it is a negative 3/2, and solve it. X is greater than or equal to negative 3/2 plus 1/2. Negative 3 plus 1 is negative 2, so I have negative 2/2. Negative 2 over 2 is negative 1. Is a compound inequality, so it's telling me both of these things are happening. So x is less than or equal to 2, but it is also greater than or equal to negative 1. But this doesn't even really matter. What matters is that we found the two x values, 2 and negative 1. And for this thing to be continuous, we need each definition of the function to equal the other at both of those x values of interest. So I need jx plus 2k to equal 2x squared minus 4 under two conditions, when x equals negative 1 and when x equals 2. So let's come up with our two equations. When x equals negative 1, well, j times negative 1 is negative j plus my 2k equals 2 times negative 1 squared minus 4. And when x equals 2, well, j times 2 is 2j plus 2k equals 2 times 2 squared minus 4. So, let's simplify it. Negative j plus 2k equals 2 times negative 1 squared is positive 1. Positive 1 times 2 is 2. 2 minus 4 is negative 2. Let's simplify the other one. 2 squared is 4 times 2 is 8. 8 minus 4 is 4. So I have 2j plus 2k equals 4. We have a system of equations, two equations with j and k, so solve it. On the left, let's solve for 2k. 2k, add j to both sides. 2k equals j minus 2. On the right, we also have a 2k, so let's solve for 2k again. 2k equals 4 minus 2j. Well, look, both of these things are equal to 2k, which means, dude, they're equal to each other. So j minus 2 has to equal 4 minus 2j. And now we have a single variable in this equation, and we can solve it. So add 2j to both sides. So 3j minus 2 equals 4. Add 2 to both sides. 3j equals 2 plus 4 is 6. So divide by 3, j equals 6 over 3 is 2. So j is 2. Let's find k. Okay, let's use this equation. 2k equals j minus 2. So 2k equals j, which is 2, minus 2. So 2k equals 0, so k equals 0, right? Divide by 2, 0 divided by 2 is still 0. So j is 2, and k is 0.